All right.
It's frozen.
You want to build a snowman?
No, don't start.
Okay, Olaf. Check it out. First thing first. I want to know what is an exponent, Bridget? Don't look, think. Don't look, think. Melanie, shh. Focus. That's okay. Yeah. An exponent is like a shorthand. Shorthand is like a symbol you use that means repeated multiplication. So what does that 2 right there tell us? So there's 2 16s and they're multiplying, correct? Okay. So then if exponents are repeated multiplication, what would maybe negative exponents be? Repeated division. Is division the inverse of multiplication? It's the reciprocal, right? Okay. All right. The tricky part, what about exponents that are fractions? Do you remember how those work? Yeah, Lauren, do you remember?
I remember.
Like here's how I remembered when I was learning fractional exponents for the first time. I'd always forget, but I remembered just this part. Like, I know what half of 4 is. I know it's 2, so I know the answer here is really 2, but not because it's half of 4. And so this is what I would remember. So I would actually write this on my test to help me like understand how to do these. So I would remember that the numerator is the exponent and the denominator is the index. So I always wrote that. That's how I'd always remember it. And it just stuck. Right, Emily, or no, Emily? Yeah. I see clearly now. No, it's singing. Calm down. Calm down.
Keep going. So the numerator is
The exponent.
and the denominator is the
Index. And that kind of makes sense. Like, let's say we had 3 to the 7th power. Would that be the same as 3 to the 7th over 1 power? Would that be the same? It would. And what would that be the same as this?
Yeah.
Like, yeah. Like what number times itself 1 time is 3 to the 7th? Well, that would just be 3 to the 7th. So I never thought about it like that, but that is the same thing. We're good? Okay. So now putting it all together. Oh. Wait, on the problem I put on the board a minute ago, was this a positive or a negative exponent?
Positive.
Positive. Man, I screwed you guys over. It should be a negative. That makes it harder. Oh, yeah. Let's do that. Oh, yeah. Man, I stole a learning opportunity from you. I apologize on it.
Okay.
I made it artificially easy. Adiyam, I like how you're wearing green today.
You got me.
Okay, George, is Melanie distracting you?
yes.
Yes?
It was inspired by Isaac.
You should make it over there.
Melanie seems awful hyper and distracted. I think she should calm down. Calm down. Okay. Check this out. The thing that's tricky about exponents is that sometimes starting one way makes it easier, sometimes starting that same way makes it more complicated. And you don't really know. So you just try something and see how it goes. It doesn't really matter which way you start as long as you're following the rules correctly, then you're fine. So like what I would do here, don't you multiply these two? Is that right? A power raised to a power, like the shortcut is, you multiply them. So what is 2 times 3/4? 3 halves? 3 halves. 16 to the 3 halves power. So we're good? Okay. And then, okay, so would this be square root or cube root? Square root, because the denominator is the index. What if what? What? I didn't hear you said. I heard what if.
I said you look good today, Cyrus.
Oh,
I didn't hear.
focus, focus, focus. Cyrus always looks good, right, Cyrus? Yeah, focus. Do you guys agree? All right. Would you agree with that so far? Leslie, are we good?
Yes.
Yeah? Okay, what's this 2 mean?
Square root.
That's how you say it. What's it mean?
Two numbers that multiply.
One number times itself that equals the radicand.
Yeah,
Correct?
that's what I mean.
I don't know. I don't even know what 16 cubed is. 256 maybe?
16 squared.
Oh, wow. So even bigger. So, wait, but we're not going to use this to do these problems. If you end up having to use a calculator for this, you're probably going to be wrong. So, I don't even know what it means. It doesn't even matter. What this means, though, is I'm looking for a number times itself. So I can simplify this. And I'm going to look for a number times itself. Would you agree that 16 is 4 times 4? Okay. And how many 4 times 4s do I have? I have 3 groups, correct? So I could write it out like this if it would help me. I don't really need to write the 2 right there, but I could write it like this. There's 1, right? Here's another. People think this is the step. It's not the step. The step is I'm looking for a group of 2, so I wrote it out to help me think about it. The thinking about it's the step. I'm looking for groups of 2. Do you understand what I mean, Miguel? This is not the step. You don't have to write this. You just have to think it. The step is the thinking it. Looking for groups of 2. Looks like I have 1 here. Correct? I have 1 here. And I have 1 here. No longer inside the square root, right? The square root of 4 times 4 is 4. The square root of 4 times 4 is 4. The square root of 4 times 4 is 4. That's 64. So 16 squared to the 3/4 power is 64. Yeah? Yes, sir?
How did you get 16 0 over 2? I mean, to the power of 0 over 2.
Because 2 times 3/4 is 3 over 2.
Oh, okay.
Yes, ma'am?
Will it always be, like, will you always be able to find such simple groups? Or no?
Usually. Yeah. If you end up multiplying this out, you're going to be wrong. Yeah. Yep. Especially because most exponent problems are on paper 2, and you don't get to use a calculator. And if you use a calculator for the tomorrow on this one, if you're going to have a problem like this, you're going to be wrong. So you're not going to use it. All right. Danny, did you get that right?
I didn't really try it because I multiplied it out first instead of computing.
Oh, that is just a sad
Yeah,
story.
I did that too.
Oh, yeah.
Yeah.
256.
Yes, ma'am.
So 64 would be your answer?
That's your answer.
Fraction exponents always make the answer bigger than the original.
No. That's smaller than the original number anyway.
So, like, bigger than the, say, like 60.
Oh, I don't know. Not always. Yes, ma'am. Michelle?
But what do you do to your index?
What do you mean? What's the square root of, look, check this out. Right? That's what we had. You don't really need to write the 2. It's if there's no number, it's a 2. Correct?
Yeah.
Would that be the same as this? Oh, wait. It was 16, not 64. I apologize. So,
4,000.
would you agree? That's what we had, right? Would you agree that that is... Would you agree with that? What's the square root of 16? 4. Where'd the square root go? Where'd the square root go? Somebody tell me where the square root went. It was part of the question. You answered the question. So where's the question go when you answer the question? It doesn't really go anywhere. It's just gone because you answered the question. This is a question. In math, this is asking a question. This is its answer. There's no more square root because you answered the question. Does that make sense? Okay. Next one. You ready? This one was easier. Yeah. If you remembered that. Now I happen to remember that the cube root of 64 is 4. 4 cubed is 64. So the cube root of 64 is 4. And I have 2 of them. That. Oh, you mean this? Yeah. I remember that the cube root of 64 is 4. Okay? I have 2 of them. So it's going to be 4 times 4, which is 16. 4 times 4 times 4 is 64. So this is the same as 64 times 64, which is 4 times 4, which is 16. Jose, we doing good? Yeah? All right. How about Jackie? Okay. If you... Okay. Oh, this is tricky right here. It's not tricky, but you guys make it tricky. You mix up a negative base with a negative exponent. What do negative exponents do? They just flip it. So would this become... Does the exponent flip? No. Okay. Because dividing by 1 over 27 is the same as multiplying by 27. Right? So these are equal. Dividing, this is division, right? Negative exponents are division. Dividing by 1 over 27 is the same as multiplying by 27. Yes, ma'am?
So it keeps its name, like it doesn't change.
Yeah, the base doesn't change. Yeah, the sign of the base doesn't change. All right, so now this is the cube root of negative 27 squared. Manny, do you remember what the cube root of 27 is? 3. And you have 2 of them, right? Can you have the cube root of a negative 27?
Yes.
What's the cube root of negative 27? Negative 3. Because negative times a negative times a negative is negative. Right? Negative 3 times negative 3 times a negative 3 equals negative 27, right? So the number times itself 3 times, it's negative 27 is 3. So that would be negative 3 times negative 3, which is... Oh, sorry, 9. Good? What other 9?
No, there's 3 negative 3s.
The cube root of 27 is negative 3 because negative... I was showing... This is scratch work. I'm just showing you what I realized. Negative 3 times negative 3 times negative 3 is negative 27. Good Melanie or bad Melanie?
Good.
Good. Yes, Leslie?
So the answer will be 9.
I don't know, would it?
I think it will.
I think it would too. Okay.